Today, I am going to do some color annealing test with a fiber laser. A fiber laser can precisely color stainless steel through a process of precise localized heating of the metal. My first step will be to run a cleaning pass across the metal. This provides an ideal surface for the colors to show up. If you do not do a cleaning pass and try to color the brushed metal surface directly, you'll end up with some coloring, but it won't be very visible straight on. This can be a pretty cool effect from an artistic standpoint, but is not very practical if you need to be able to clearly see the markings. To run a test pattern, I am going to make a grid of various settings in Lightburn. In this example, I will be setting the frequency to a range from 150 to 450 kilohertz and an interval of line spacing from 0.001 to 0.005 millimeters. I will then set the count so that it gives me a 20 by 20 grid of 2.5 by 2.5 millimeters each. The first step is for the laser to mark the parameters for the X and Y axes. The other parameters that will not vary will be marked on the top. Next, the laser will make the test sample box for each of these parameters. Depending upon these settings, the test can take quite a while. Laser marking stainless steel in precise colors is a slow process because the metal must be annealed at a controlled rate and intensity. The parameters of power, frequency, line spacing, pulse length, and speed can all be varied to change the results. Every time you change the lens or the material you're marking, all the parameters will need to be adjusted. Here are some results. As you can see, you will go through a ton of samples trying to dial in your parameters. However, once you know your machine, it'll be easier to dial in for future jobs. It is hard to see all the colors as the lighting and angle affect it a lot. Here are some samples of a project I am working on with the pentacle moon phase design.